And now, a very important topic: tail dependencies. These dependencies will be discussed here using the lambda L and lambda U measures. These are indicators that respectively measure dependencies in the lower tails of the variables, where they take on low values, and in the upper tails, where they take on high values. The Gaussian copula, which belongs to the elliptical copulas, has lambda L and lambda U values equal to 0. This means that the Gaussian copula does not allow us to measure dependencies in either the upper or lower tails. However, when it comes to the student's T copula, the lambda L coefficient, which measures lower tail dependencies, and lambda U, which measures upper tail dependencies, are expressed using the same formulas. This implies that the lower and upper tail dependencies are symmetric. They are measured using the cumulative distribution function of the student's T distribution, with the degrees of freedom equal to nu plus 1. In the case of the T copula, lambda L and lambda U depend on nu, which is the number of degrees of freedom for this copula, and on rho. It is evident that as nu increases, the values of lambda L and lambda U, since they are identical, decrease in the same way. Conversely, when rho increases, meaning that the Pearson correlation between the variables rises, lambda L and lambda U also increase in the same manner, as these measures are symmetric. For the Clayton copula, it is clearly visible through the values of lambda L and lambda U that this copula models lower tail dependencies. Lambda L is not equal to 0 and increases as the value of theta increases. However, when it comes to the upper tails, meaning the dependencies between variables when they take on high values, lambda U is equal to 0. The parameter theta, which characterizes the Clayton copula, does not affect lambda U. For the next Archimedean copula, the Gumbel copula, the situation is reversed. The lambda U measure, which quantifies upper tail dependencies, is non-zero and depends on theta in the following way. If theta increases, the level of upper tail dependence also increases. However, in the case of the lower tails, lambda L is equal to 0. This means that the Gumbel copula is designed to model upper tail dependencies when random variables take on high values in their distributions. However, when they assume low values, the Gumbel copula does not reflect such relationships in the lower tails.